Hi guys, today we're gonna be solving some fun equations. Yeah, because all equations are fun. Some of the equations that we're gonna solve are linear, some of them are gonna be rational. One of these bad boys is gonna be an identity, one of these is gonna be an inconsistent equation. Now, what is an identity? An identity is the special name given to an equation whose solution set is given by the set of all real numbers. So if the solution set is given by the set of all real numbers, then you can just write all real numbers, or you can use the symbol for it in set notation, which is the double bar R. So I don't know if I said that right, but I can write it correctly. So pretty much it's an uppercase R with an extra vertical bar. Okay, doubled bar R. Yeah, you understood me. Cool. Now, what is an inconsistent equation? An inconsistent equation is the special name given to an equation that has no solution. So if the equation has no solution, then there's no way you can find the x equals this or x equals that. And if the equation has no solution, you can either write the words no solution, you can write the empty set, or you can use the null set. Okay, so ask your instructor. Okay, so let's go ahead attack fun problem number 1. We are asked to solve each equation algebraically. And a gentle reminder, unless the directions say round to this place value, we always want the answers in exact form. So problem A, we have 2 minus 3 times the sum of 2 and 6x is equal to 4 times the sum of x and 1 increased by 36. Fantastic. So let's go ahead, take our time and clear those grouping symbols. So that will give us 2. We'll distribute the 3. If we attach the subtraction sign to it, we'll say distribute negative 3. So that will give us negative 6 minus 18x is equal to, let's go ahead, clear the grouping symbols on the right. Product of 4 and x is 4x, and product of 4 and 1 is 4. And we're pretty good. Okay, so grouping symbols are gone. Let's just make sure that we continue to simplify each side. So let's go ahead, combine the like terms. So on the left side, we only have one variable term. But on the right side, difference of 2 and 6 will give us negative 4. And that should equal 4x plus the sum of the constant terms, which gives us 40. Cool. So each side is simplified, but now the problem is that we have variable terms on both sides, and we need to fix it so they're on the same side. If I can read your mind, I think we're going to add 18x to both sides. And if I couldn't read your mind, it's okay. The reason why I decided to move the negative 18x as opposed to the 4x is because I wanted to ensure that we had a positive coefficient on x. You know that me and negatives don't get along. Okay, cool. So before we had variable terms on both sides, thanks to our hard work, we now have them on one side. So let's go ahead and work our magic to isolate the variable term. So if you're not with the x, you gotta go. Opposite or undoing of addition is subtraction. So that's how we subtract 40 from both sides. And that will leave us with negative 44 is equal to 22x. For the grand finale, to get rid of the times 22, let's go ahead and divide both sides by 22. And that will leave us with x equals, I believe, negative 2. Cool. All right, so the question is, do we have to rewrite it so the variable is on the left? You know, that's a personal choice, but it doesn't really matter. When it comes to equations, how do you know when you're done? You're done when you've isolated the variable. Variable is by itself, so we're good. So that was the first of 4 problems. Let's go ahead and knock out the next problem. Problem B, we have, where am I? Oh, so we have 7 over 3x plus 2 is equal to 1 over x minus 3/5. So in this case, we have a rational equation, or an equation that has fractions. So I need to watch out to see if we have any restrictions on the variable. So I want to know, is there at least one denominator that has a variable in it? And unfortunately, the answer is yes. So we have to watch out for restrictions on the variable. To find the restrictions on the variable, you want to tell yourself what makes the denominator equal to 0. So if the first denominator equals to 0, after we divide both sides by 3, that will give us x equals 0. So we want to tell the world x cannot equal 0. The next denominator, when you set that equal to 0, that's it, you still get 0. So same difference, okay? So the restriction on the variable is that x cannot equal 0. So what after we finish solving the problem, let's just make sure that it doesn't equal 0. What's going to be the big deal? If it equals 0, 1 over 0 is 0, and then quotient is undefined, similar for over here. Alright, so the next question that I get asked is, do we really have to clear the fractions? You don't. It is a personal choice, and I choose to take it. Okay, so let's go ahead and wipe out the fractions by multiplying both sides by the least common denominator that we're about to identify. So the denominators are 3x, x, and 5. So the LCD between 3 and 5 is 15. I'm out of space. For the variable factors, LCD between the x's is going to be x. So altogether, the least common denominator between 3x, x, and 5 will give us 15x. So let's take our time. Go ahead, wipe out the fractions by multiplying both sides by the common denominator just found. Oh, I ran out of space. Let me go ahead, put it as a thinking area. All right, let's do this. So 15x times the first thing that we see, 3 goes into 15 5 times. Quotient of x in itself will give us 1, so that will leave us with 5 times 7, or 35. It's a personal choice. Maybe we should have went to answers, but when you're a little bit sleepy, you can't do too much mental math. All right, next distribution. Product of 15x and 2 will give us 30x. Okay, this is in my way. Let's cross it out. Equals, on the right side, 15x times the first thing that we see. The x has to cancel out. If it doesn't, then this is not a common denominator. X goes into 15x exactly 15 times, and that will leave us with 15 times 1, or 15. Next product, 15 times negative 3/5, that will give us negative something. 5 goes into 15x exactly 3x times, and that will leave us with 3x times 3, or 9x. Fantastic. So we have variable terms on both sides, same speech as before. We want to fix it so they're on the same side. In this case, I'm going to go ahead choose to add 9x to both sides, because that would allow me to avoid having negative coefficients. So if we go that path, that will leave us with 35 plus 39x is equal to 15. Work your magic. Isolate the variable term. Let's go ahead, subtract 35 from both sides. And when we do, that will leave us with 39x is equal to negative 0.2, or negative 20, like normal people speak. We take our time to get rid of the times 39. Let's go ahead, divide both sides by 39. And that will leave us with x equals negative 20 over 39. How exciting. Fantastic. So that is the second of 4 problems. Let me go ahead, grab a sheet of paper, and I'll be right back. And we're back. Okay, so let's go ahead and solve this bad boy, or equations, how normal people speak. So first thing we want to do is clear the grouping symbols, and then simplify the left and right side. So on the left side, let's go ahead and distribute the 5. That will leave us with 5x plus 10. Let's take our time to distribute the negative 2, and that will leave us with negative 2x minus 2 equals the right side, which was already perfect. Before I even think about what we're going to do to both sides, we need to make sure that both the left side and the right side are simplified. The right side is cool, the left side not so much. When we combine the like terms, the sum of the variable terms, namely 5x and negative 2x, will give us 3x. And the sum of the constant terms, 10 less 2, will give us 8. It's like, oh, I'm so proud of us, guys. Fantastic. So now, at this point, we have variable terms on both sides. We need to fix it so they're on the same side, or only on one side. It's the same variable term. Depending on your book may say, quick, what's the answer? But I think it's a little bit too early to answer, because if I answer right now, I kind of feel like I have to memorize things. And remember, I memorize what I have to. I understand as much as I can. So for me, I'm just going to be like, let's fix it so we only have x on one side. So in this case, we'll subtract 3x from both sides. Which variable term did I move? Did I move the left one? Did I move the right one? You know what? I moved the one that you were thinking. Cool. All right. So when we subtract 3x from both sides, that will leave us with 8 equals 8. And I'm really having a moment, because I'm like, oh, should I subtract both sides by 8? I mean, you could, but I don't recommend that you do. We were trying to solve for x. We were not trying to solve for 8. So when we're solving equations, if all the variable terms cancel out, I need you to ask yourself, do I have a true or false statement? Okay, do I have a true or false statement? Last time I checked, 8 does equal 8. So we have a true statement. So the moral of the story is this: when we're solving an equation, if the variables cancel out and we end up with the true statement, then the solution set is given by the set of all real numbers. You may want to put like the pound sign or number sign, but we don't want hieroglyphics, okay? Yeah, you can't read my writing, pretend you can, okay? So we write all real numbers, or you can write it in set notation with the symbol. It's up to you. Of course, the symbol is faster, but I don't really like it because it requires for me to memorize it, and then it requires that I remember. Sorry, I don't like to use it because two things. One, it requires that I remember it, and then two, it requires that I remember what it represents. Yeah, talk about tongue twister. You know, what could a woodchuck chuck if a woodchuck could chuck wood? Yeah, that's easy. Me saying what I'm trying to say, not so much. All right, for the grand finale, let's go ahead and knock out problem D. And that reads 2x over x plus 10 is equal to 3 minus 20 over x plus 10. So in this case, we have another rational equation. Because we have a variable in at least one of the denominators, we gotta watch out for restrictions on the variable. So restrictions on the variable, that is just code for what makes the denominator a 0. If you want to know what makes the denominator 0, let's go ahead, take a denominator and set that equal to 0. So when you take the first denominator and set that equal to 0, that will give us negative 10. So we want to tell the world, x cannot equal negative 10. We don't have time to write all those words, so we'll just write x does not equal to negative 10. The next denominator is the same, so there's no need for us to do an instant replay. All right, cool. So now the next question that I get is this: do we really have to wipe out the fractions? You don't, but if you know me, you know I am. The LCD, in this case, the denominators are the same, so the LCD is just that same denominator that is recycled. So let's go ahead, try to wipe out the fractions by multiplying both sides by the common denominator just found. So after we multiply both sides by the LCD, all the fractions are gone, should be gone. If not, let's go ahead, check our supposed common denominator. On the left side, we have a straight multiplication problem. There's no distribution, so I'm going to go ahead and use our cross-counting notation. Quotient of x plus 10 and itself will give us 1, so that will leave us with 2x. On the right side, x plus 10 times 3 will give us x plus 10 times 3. We keep it going, x plus 10 times the next thing that we see. The x plus 10 has to cancel, and it does, and that will leave us just with 20 negative, okay, or negative 20, how normal people speak. All right, we got this. We're almost free to go. So let's go ahead, take our time, clear that grouping symbol. So when we do, product of 3 and x is 3x, product of 3 and 10 is 30. Bring down the rest of the problem. We're on it. Let's go ahead, continue to simplify, in this case the right side. Difference of 30 and 20 will give us 10. Under normal circumstances, I would move the 2x to avoid having a negative coefficient, but right now it's time to face my fears, because ultimately I want variable terms on one side, constants on the other. So if we move the 3x, then we'll have variables on one side and constants on the other. So yeah, time to face our fears. Cool. So if you choose to subtract 3x from both sides, that will leave us with negative x equals 10. And the variable is almost isolated, but not quite. To undo the times negative 1, let's go ahead, divide both sides by negative 1. And that will give us x equals negative 10. And I know we nailed it, but then I checked the back of the book and it's like, oh my goodness, that's not the right answer. And I'm like, why not? We didn't make an arithmetic mistake. That is correct, we didn't make an arithmetic mistake. But remember what I told ourselves. We told ourselves that the restriction on the variable is that x cannot equal negative 10. What do we have? X equals negative 10. And that cannot happen because if x equals negative 10, guess what's happening? Negative 10 plus 10, 0. And we cannot divide by 0 because that will make it undefined. So we did not make a mistake. This is just an extraneous solution. Oh, will we have to write these words on the test? Of course not. Okay, the directions were solve, so spit out the answer. In this case, I just want to talk to myself. An extraneous solution, what is that? An extraneous solution is a solution of one of the new equations, but not of the original equation. So I guess in this case, it's a solution of this linear equation, you know, the one without the fractions. So what's going on? So we have one oh, that's not a nice finger. Oh, I need a manicure. We have one possible answer. That looks even worse. We have one possible answer that couldn't fly. Since we have nothing else to go by, then there's no solution. Okay. So again, you can either write the words, or you can write the empty set, or you can even write the null set. Okay, I like the words. Okay, the words, I don't have to remember symbols or anything. Fantastic, guys. So we did it. Thanks.